Okay, so what we're going to do now is take a look at how does the copy rotation constraint work when you are telling a child object to copy the rotation of its parent. Now, this is going to be very tricky to visualize is because when you click on the parent and press the R key to rotate, the child will always follow whatever the parent is doing, okay? So what I want you to do is go ahead and click on the child, do Alt R to reset its rotation first, and press the R key to change its rotation in its local coordinate system. Now go ahead and do copy rotation, and here we're going to copy the rotation of its parent. Now over here, we're evaluating both objects in world space, right? So we know that the parent object only knows how to operate in world space, and the child object only knows how to operate in local space. So here what the child object is doing is simply looking at the parent in world space. So when we click on the parent and press the R key to rotate, the orientation for both objects are always going to match, right? Because if this is how the parent is, its orientation in world space, then the child is going to do the same thing. So you can press the G key and actually move the child a little closer to see that this is what's going on. I'm going to put this back here. I'm going to actually click on this axis and press the S key to scale this a bit so we can see the difference. Now go ahead and click on this child. Now here what we're going to do is going to start to get very tricky to comprehend. Here we're going to tell the parent, which only knows how to operate in world space, to operate in local space. Now you'll see that what happens to the child. Let's first understand what's going on with the parent. We've already seen that when we are working with an object that has no parent and look at it in local space, Blender is simply going to take the axis that is being displayed on the object itself and make that its a local coordinate system. So meaning that this guy over here, visually, when this object is looking at their parent, actually does not count. What this object is really doing with this axis is that it's simply looking at it as if the axis is stuck to it like this, right? Because that's what local space is for an object that exists in world space. So this y-axis will always be aligned to this axis, meaning that when we press the R key to rotate this, right, it will never move away from its coordinate system. So the values will always be 0. These numbers do not matter because this is all about world space. In local space, because it cannot move away from its y-axis, here if you look at the child, you will notice that when we click on the parent, the child simply always matches the world coordinate system. See how it's rotating? So we can actually click on the child and move it over here and take a look at what it's actually doing. See how it's behaving? Because there are no rotations coming through. So that's how that concept is going to work. Remember, this over here, the only reason we did this is just a visual thing to show that how the child is looking at the parent's coordinate system. That's what's going on. Now what we're going to do is actually turn this off. Go ahead and click this. Now we're going to say that, okay, since we've seen how this works in world space and world space, local space and world space, what happens when we switch this to local space? Okay, so now you'll see that the child is simply just going to match its own local coordinate system. This is because when we look at the parent and actually go back over here and turn this on, you see that when we rotate the parent, there are no rotations coming through. So the child is simply just going to align itself to its local coordinate system. There's really nothing for the child to do here, right? And now when we're moving the parent, of course, the child is just going to follow it anyways. That's how that concept is going to work. Now, when we switch this to world space and keep this at a local space, you'll see that over here, we actually have to turn this off to see what's going on. Now you can see that this is actually pretty straightforward. What we have to do is click on this child, do Alt G to see what's happening, right? If you click this, press the R key, you'll see that the child is doing the same thing. But because it's rotating at the same time, it also rotates. Okay, so that's the first part of this concept. Now, the other part that I'm going to show you is actually very difficult to even see on the child. It's because when we click on this parent, press the R key, press the Y key to rotate around Y, the child is also going to rotate around Y. Now you have to visually think about what the child is actually showing. See, it's rotating around Y, and at the same time it's rotating with the parent. Look at the y-axis on the child. If you just stare at it, you'll see that it's actually just rotating around itself. That's what's going on. Okay, so now over here, when we click this, here we can see that when we rotate this parent on its y, the child is of course going to rotate on its y. Press the R key, press the Y key. Again, this is very difficult to see what it's doing. Okay, so that's how that concept is going to work. Now, of course, if we switch this back to world space over here, right, the question is going to be that, okay, so if we rotate the parent on the y-axis, how is the child going to rotate? Of course, the child is going to rotate on the same y-axis that is being displayed on the parent, because we are evaluating the child in world space. Now, we're not going to be able to see this very clearly. Press the R key, press the Y key. See, it is rotating, but we can't actually see it. So that's how that idea is going to work. Anyways, I think you understand what is it that I'm showing you here, right? It's a pretty straightforward concept. This is why it was important to look at it here first so you can understand it before we got into this. Now, I'm not sure if you will ever use this technique where you're telling the child to copy the rotation of the parent, but it's good to understand what it's actually doing. So anyways, what we need to do now is go ahead and now move forward with bounds. So what I want you to do is now press the A key to select everything, do X and delete. Do Shift C to place the 3D cursor in the center, do Shift A and add an armature with a single bound. First, I have to show you something really important. So press the 1 key to go to your front view. Now go ahead and go to the Object tab, enable the axis, go to the Data tab and enable the axis and names on the bound. Now, we're actually not going to save this file, we'll just reload it, but I just want to show you that go ahead and click on this red arrow and just move it away from its origin point. Now, as I've already shown you that when objects enter inside the 3D view, they will always be aligned to the coordinate system that they are using. This is also true for these bounds. So now when we switch to edit mode and click on this bound, you can see that Blender is adding this bound vertically, right? So if we click on this x-axis and move this bound over here, do a Shift A to add another bound, you'll see that it always appears vertically. But if we look at the axis that is being displayed over here, tells you that this bound was rotated. Okay, so what does this mean? This means that first of all, that if you switch to pose mode and let's say click on this bound, press the Shift key down and click on this one, do Shift Control C and do copy rotation, click on this bound, go to the Constraints tab, you can see that because this bound was rotated by 90 degrees, right? When we click on offset, you'll see that it's going to move forward like this. So what's actually going on here is that first this bound is looking at how this bone's orientation is. But because this bone internally in edit mode has a rotation, that is going to get added. So this is not a big deal because you can simply press the R key to rotate the bone back, right? Because we have offset checked. But here I just want to show you where this is coming from. It's actually coming from edit mode, right? So go ahead and click on the tail of this bone. Press the 3 key to go to your right view. Press the R key, press the Control key down and rotate it down. right? So here, if you click on this bone, you can see that here right now, the axis is aligned to the global coordinate system. This means that this bone does not have a rotation. So now when we go to pose mode, click on this bone and click on offset, you see there's no rotation to add, okay? So that rotation is going to come from edit mode, right? So if you change the rotation, see how this Z, Y, and axis is on this bone. When you press the 3 key to go to the right, you click on the tail. When you press the R key, you can see that the axis is changing on the tail. This means that we're actually rotating this in edit mode. Okay, now this information is not going to appear. Again, you can use the same idea from the Pythagorean theorem to understand where these rotations are coming from, right? So over here, when you click on the tail of this bone, you can see over here that we're seeing the location of the tail itself from the origin point, how far it is away from it, right? Same thing for the head. The head is showing how far it is away from the origin point, which is here. See, along the x-axis over here, if we type in 0 over here, you'll see the head moves, and if we type in the tail, type in 0, the tail moves. Okay, so if we click on this tail, press the 3 key, press the R key to rotate all the way down. Right now we don't have any rotations. Okay, so because this bone is a length of unit of 1, if we click on the tail, press the R key, press the control key down, and do 5, 10, 15, 20, 25 over here, we'll see that it's doing the same thing, right? Now here we're not dealing with the y and x axis, we just have to think ourselves, right? When the axis is going up and down, this is your y-axis, and this would act like your x-axis, meaning that this would be your sine value and this will be your cosine value. Okay, so if we bring up the calculator, we can see this over here, right? On a scientific calculator, this is your y-axis and this is your x-axis, right? And this is of course your tangent. So if we just look at the tail of this bone, when the bone is positioned exactly to where the origin point is, we can do the same thing. We can look at the z value as the y-axis, right? We have to visually look at this and say that, okay, that's a dot 423. So here we can do dot 423. Because it's a length of a 1, all we have to do is click on this guy over here to get the inverse. And here, because we're looking at the the up and down, which is considered the y-axis, it doesn't matter if it says z. Here we can just do inverse of a sine. It'll give us 25 degrees, right? So in the same way, when we look at the cosine, which is dot 906, dot 906, get the inverse cosine, we will get 25 degrees over here, right? Now, if you go ahead and do it the other way, if you do dot 423 divided by the cosine dot 906 equals, and you get the inverse tangent, you'll get 25 degrees, right? So if you want to understand this a bit better, you can simply just go to this tab and click on stick mode. And here, if we go ahead and click on the grease pencil over here, we can just draw a line right over here. It's just a right triangle, right? The Pythagorean theorem, same concept, right? I'm just going to X this out. And now, of course, you can also click on this ruler, press the control key down and drag it over here like this. And see the same thing appear over here. Right, 25 degrees. Press the escape key to get out of the ruler. Now, what we're going to do is actually take a look at this in a different way, right? Because in edit mode, we can only see really how far the tail and the head is from the origin point. there definitely are rotations inside here that are not coming through in pose mode. Okay, I'm going to switch this back. They're not going to show over here, right? This is something that's happening internally in edit mode. So what I want you to do is go ahead and do click on this armature and do Alt G to reset its location. Press the tab key, click on this bone, do X and delete, click on this bone, do X and delete, do Shift C to place the 3D cursor in the center, and just do a Shift A to add a bone over here. Now we're going to take a look at where this is how the rotation is actually buried inside this bone in edit mode. So to do this, what you can do is just do Shift A, and here we can just add a circle. Press the 7 key to go to your top view, and over here I'm going to actually press the tab key to go into edit mode, and in this case right now I'm just going to click on this vertex, do Control I, do X, and delete all the vertices. So we should only have one vertex. Press the tab key. Now since we have the circle selected, we can go ahead and go to the modifiers tab and click over here, and here we're going to do a screw. Okay, so this is going to add this. So over here you're going to steps to 360, enter, and over here that when we remove this, you can see that we start to get numbers over here. So all we have to do is actually click this, and here I'm going to show you something a bit advanced which we're going to encounter a little later. Over here I want you to do add a driver and do manually create a later. So here we can inject values from the bone rotation itself to see what it's doing. So to do this, what we have to do is actually open this up over here, go to the graph editor and switch this to drivers. We're going to talk about this a little later. I just want you to do drivers over here. So here you can see that this is the variable over here, so just type in VAR. We want to use that. Over here we're of course going to click on armature.01 because that's what that is, and over here we're going to get a bone, and we're going to say that okay, give us the rotation on the x-axis, right? So here we have to do x rotation. Notice that what it's doing, it's showing you that there is an internal rotation coming of 90 degrees. This is what's happening over here, right? So go ahead and just close this up. Now over here what we're going to do is click on, just have the circle selected, and I'm going to press the 7 key, press the R key, and just press the Control key down and rotate it by 90 degrees. I'm looking at the header over here to do that. Okay, so I'm going to press the R key, press the Control key down and move it one time over here, press the 1 key, press the R key, and now just rotate it over here. Press the 3 key. So now you can see that here when we click on this bone, go to edit mode, click on its tail, go ahead and just zoom in, press the R key, press the Control key down. When we rotate this bone like this and now switch back to pose mode, notice that how this is changing. It's showing you that there is an internal rotation coming out from the bone itself in edit mode. Okay, so I just want you to keep this concept in mind that when we are going to be looking at the copy rotation constraint on bones, we have to understand that this guy is always there. Okay, anyways, go ahead and now just reload the file, press the A key to select everything, do X and delete. Now go ahead and switch back to our original thing over here, click on the bone, press the period key to home in on it, and here I'm just going to rotate it like this. I'm going to do a file, save as, and save this as bone concepts 10.blend. So I'll see you in the next lesson. Thank you.